So part of that homework was to calculate the, is that the hypotenuse, the diagonal of an x and a y. And there's a formula for that. I give you the formula. And then I told you kind of a quickie little hack to calculating the square root. But Python has a built-in square root function as well. Not built-in. You have to import the math library. Once you import the math library, then it's built in. Kind of built in becomes the Python includes the math library. So anyways, I wanted to demonstrate that really, really quick. So I'm going to launch idle, go to new file. In the very top line of my code, after my comments, right, you know, guess we're on lecture F, etc., etc. Okay, so say we needed to take the square root of 10. Here's what I had you do, or at least I suggested, and I also said go ahead and Google it. And if you've done Python programming before, you also know about the math library. So A is equal to 10 star star 0.5. That's one way to do it, but it's pretty oblique. It's kind of, if you didn't know what it meant, you would not know that that was taking the square root. You'd have to at least add a comment to that effect, right? Square root. I'm pretty sure I misspelled square there. Of 10. Here's a better way. Now that we've imported the math library, we can just do this. Math dot, is it HQRT? Like that. Right, and that's real clear. I think I used the term magic numbers at one point to describe numbers that you put in your code, you know, that don't make sense to anybody else, right? You know, why is this if limit greater than 97? And you go, well, I don't know why it's 97. I have no idea, you know. Or if number of users equals 364, you don't know why that number 364 is there. In this case, you wouldn't know why that was there unless you were, you know, cognizant of the fact that that's a quickie way to take the square root of something. So this is a better way. It's good to mention the import math statement because, well, for one thing, there's a million different functions in the math library if we go and look them up. There's one called ceiling, .ceil. There's one called .floor. There's factorial. Factorial is 1 times, 2 times, 3 times, 4 times, whatever. F-sum calculates a floating point sum using better precision than just the sum keyword does. Well, hey, there's an example of floating point rounding error. I kept fumbling looking for an example of floating point rounding error. That looks like it's 1. I'm going to see if I can replicate that error in a slightly different way. A is equal to 10. No, it was doing 10.1s that caused a problem. So x is equal to 1. X minus equals 0.1. And then just repeat that. Copy that and paste it so that it's 10 times. That's 2 times. 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. And then print x. Let's see if it prints 0, which is what it should, right? Because we're subtracting 0.1 from it 10 times. That should come out to be 0. It came out to something, but not 0. A very, very, very infinitesimally small number, you know, a point followed by 15 zeros and then a 1. Obviously, that's supposed to be 0. That's an example of floating point rounding errors because of the impossibility. Well, I won't say it's impossible, but the way computers store floating point digits is that they convert them to binary powers of 2, which works great for everything greater than the decimal point, but for less than the decimal point, it's only an approximation. Just like when we express 1 divided by 3 in decimal form, we put 0.333, you know, as many 3's as we can carry, but we can't carry an infinite number of 3's, so it's only an approximation. All right. I find that fascinating. Anyway, so we'll hit upon the topic of floating point rounding errors at a later point. I'm just not happy to have such a clear one there. If you need to use functions within the math library, you prefix them with the word math dot, right? Suppose you hate the way that looks. You can do this. From math, import sqrt. And then you can do a is equal to math, excuse me, that's why I did the import in that way. A is equal to sqrt parentheses 10. Like that. Two different syntaxes. This one brings in the library and makes it all the functions available for use. And to use them, you have to prefix them by their library name. This one brings it in such a way that we don't have to prefix it with its name. If you want to bring in all of the functions like that so that you don't have to prefix them with the math dot part, you could do from math import star. That does the same thing. A is equal to whatever another one of those functions was. Ceil. S-E-I-L. Excuse me. Yeah, C-E-I-L. Parentheses 0.9. B is equal to C-E-I-L parentheses 0.9. All right, what is, excuse me, I wanted to make that floor. Make the second one floor. And now I'm going to print A comma B, just because we've been doing a lot with A, and I mean, may as well see what it's doing. Check out what it did here. What does ceil mean? It took 0.9 and it rounded it up. But it didn't exactly round it up. It kind of forced it to be up. So 0.9 became 1 when we called ceiling on it. And floor rounded it down. But again, it didn't really round it down. It truncated it, terminated it with extreme prejudice. If we took the ceil of 0.0001, it's still going to be 1. Right? Because it's not 0. It's not exactly 0. So it's going to round it up. And if we took the floor of 0, point, something like that, this is going to be 0 and this is going to be 1. Got that backwards. That's a 1 and that's a 0 because ceil rounds it up always, no matter what the fractional component is, and floor always rounds it down. So no matter how many 9s we had there, this one would round down like that. Okay, so in our equation, when we were doing the diagonal equation, when you did the expression, let's say height is equal to 5, width is equal to 5, diagonal is equal to sqrt parentheses h to the power 2, h star star 2 plus w star star 2 in parentheses, and we print d out. Guess I should print a capital D. There we go. I don't know why I made them all capital letters. Let's go ahead and run it. And we get a very long answer. Lots of ways that you could reduce that to a more pleasing thing to see. In my homework instructions, in the hints section, I mentioned that you could use the round function. And you could. Yeah, if you print round parentheses d comma 2 in parentheses, it'll round it to 2 decimal places. Or you can use formatted print statements, and I'm pretty sure that I've mentioned these before. I'm going to mention them again because they're so handy. Print the diagonal, okay, if I could spell it, diagonal is, I'm just spelling it completely, I'm just going to say diag is %.2f, meaning 2 places after the decimal point for a floating point number. Man, I botched that completely. Where'd my H go? There we go. End quote, %sign D in parentheses. So that's a formatted print, and I believe I've showed you all that there's an alternate syntax for the formatted print, which is actually the newer, more preferred version, but this way is so deeply ingrained in my brain that I just default back to it. When we talked about PEMDAS, P-E-M-D-A-S, order of precedence, order of evaluation, P-E-M-D-A-S, parentheses first, and the exponents, and then multiplication and division, either one of those two. And then addition and subtraction. There's one more technically. Also the minus sign. Slightly confusing, but what does it mean when I do this? X equals minus 1. This is called the unary negation. Unary meaning that it's only got one operand. This is the value, the operand that it is acting upon. And the unary negation takes whatever number is after it and flips it, right? Changes it from positive to negative. It's a weird way to think about it. We don't think of it that way at all. We just know, oh, there's a negative sign there. It's a minus sign. It means it's a negative number. So the textbook goes to the trouble of pointing out that unary negation is evaluated next, before all the multiplications and the subtractions and the divisions, which kind of makes sense. If we had this, x is equal to 3 times minus 2, that has to happen first, right? It has to be converted to a negative 2 before it can be multiplied. I'm not going to, I'm not going to ask where unary negation sits on the order of operations table. If we wanted to, we would insert it right there. But I may as well add that as a comment. Minus 9, the minus is called unary negation. And has higher precedence than anything other than star star. Now, technically speaking, the parentheses are not part of this table of ordinary order of precedence because these are not mathematical operators, right? They don't do addition, subtraction, multiplication, or division. Instead, they do grouping. But this is how we learned them when we were a kid. Learned PEMDAS, if you learned that silly phrase. Please excuse my dear Aunt Sally. So somebody came up with that witticism, that mnemonic. I won't ask that on an exam about unary negation. If it's a quiz question, get it right and then didn't forget it. With two exceptions, operations of equal precedence are left associative, so they are done from left to right. And it's saying, other than that though, star star is done right to left. I'm not going to concern myself with an explanation of that. Left associativity just means that if you did this, a is equal to x plus y plus z, that it gets done in that order. Left, 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 right, from left to right. That's left associativity. The textbook is mentioning that star-star's associativity is right to left. I guess that's like saying, if we have that, how would we evaluate it? Would we cube it first and then take it to the power of 2? That slide states that we would do that part first. We would take 3 to the power of 2, which is 9, and then raise a to that power. Now, honestly, you'd get the same answer either way, so I'm not sure why that's a big thing to point out. But pretty much all other math assignments, go left to right, as long as it's in the same precedence category. Did I mention last time that this statement is a complete lie? I think the author of this textbook took another textbook for another language and modified the information, because this is not true. 3 divided by 4 is not 0. We could prove that. Some languages it is. It's not a ludicrous statement. But if I come here and I say a is equal to 3 divided by 4, and then I print out a, it's not 0. It's 0.75. This slide is whatever. Yeah, so we'll look at it just for a second more, because when you go on and you take Java or C++, this is actually true. If you have 2 integers, integer division always produces a integer, right? And so if you have 2 whole numbers and you do the division and then you have to round down, well, if the result is less than 1, right, like 9 divided by 10, 9 divided by 10 rounded down is in fact 0. So an integer divided by an integer will round down to a 0 in those languages, just not this one. So we have the conversion functions. We've been using this one a lot. Turn something into a float. And I don't know why they give us 2 examples here and only 1 example here, but right. We've done that. This is how we've been using it primarily. Pass in a piece of data into the float conversion function, and it returns a float. Well, I munched that up. You can also convert an int, a string, to a float, but you can also convert a string to an int. The problem is that if you call this, but you give it a floating point value rather than an integer value, it'll crash. You have an error that you need to catch. For example, just go back to the shell and do it. We asked them for a number and the user typed in 3.0, and we wanted to convert that to an integer for some reason. If we do this, int parentheses a, it says that's an invalid literal for int. But this is a valid float, and the int function will take a float as its argument. So although this looks dumb, it works. Int parentheses float parentheses a gets us that it's that. So if you really need to convert user input to an int, and you're not sure whether the user is going to put a decimal point in it or not, and it's okay to round down if they do, then you can do that. Instead of just doing int a, or a is equal to int a's, what we had been doing, that's the syntax we'd been using with float. We could do a is equal to int parentheses float parentheses a, like that, and then it converts it to an int. I don't know how many times I can't think of a circumstance where I want to force input to be an integer in that fashion. Did we talk about the way to capture errors so that they don't crash your program using the try catch words? Have we done that? All right. If you've been mentally checked out for a while because I'm boring, tune back in for a second because this is useful information. Go ahead and just add some kind of input statement here, like a equals, wait, let's print out what we were asking for. Print, enter a number, and we do a is equal to input parentheses in parentheses, and now we're going to convert it to a float. A is equal to float parentheses a. We can be pretty sure what's going to happen when we run it. So diag is 7 points. Enter a number. All right, but if I type in garbage, it's going to crash, and we've seen this before. Cannot convert a string to a float. You don't want your program to crash when somebody makes a mistake like that. You can capture that error. You can catch the error with a pair of keywords. This is the risky statement. That's the one that can blow up. So I'm going to stick a try in front of it. Try, colon, everything after a colon has to be indented. And then catch, colon, this is unindented. We're going to tell the user what happened. Print, that was not a number. Using one as default, or something like that. Just giving it a default value. Go on our merry way. And now print, the number is in quote, comma a. Ooh, look at that. I used the wrong word. I use the word that you use in Java and C, C++. In this language, it is except. Sorry about that. Delete your word catch there and replace it with that. All right. It's asked me to enter a number. I give it a good number. Great. It tells me the number is 9. Everything went as planned. Enter a number. I type in some garbage. It says that was not a number, using one as default. The number is 1. Now, there may not be that many times where you want to assign a default value if the user entered bad data. A better way to do it would be to put it in a loop and to require them to enter good data, right? We could write some code like that instead. Not that we've done a lot of loops yet. That's why it's taking us so long to get through chapter 2, is because I like jumping ahead, but we're going to do it. So, why don't we... I am gonna skip what I was just talking about. Hit the chapter. Stick to the chapter for a bit. Why would you ever want to convert anything to a string, right? Numbers are great. Well, sometimes you want to build a string for whatever reason. If we want to print something, right, it's real easy to print the number is comma a. But if we wanted to store that in a string to write it out to a file or something like that, and so I tried to do this, text equals quote, the number is end quote comma a, looks good because that's how we've been printing it, but that's an error. It's a syntax error. Or so I said. Okay, it's not a syntax error, but it is not what we wanted it to do. I'm going to comment out this line here. And I'll show you what I mean by it's not what I wanted it to do. All of a sudden, the output has these weird parentheses around it. It created what's known as a tuple out of our input. And honestly, didn't know that you could do it without putting parentheses around it. What's important to note is that it did not do what I thought it was going to do, which is just add that number onto that as pure, plain, clean text that when we printed it out made it look as good as what we had done before. So what you would want to do is you'd want to put a plus sign there to append. Now you can probably guess that's not going to work because we have a number and we can't append a number to text. It says must be a string, not a float. But we can convert A to be a string so that it can be concatenated, so it can be appended to that other string. And now I just have one little glitch, which is that I sure would like to have seen a space there, and I can fix that, right, just by putting a space there. Are you usually going to go to the trouble of preparing a string before printing it? No, but what if I wanted my output to look like this? A equals 7.0. Right? That's what I want it to look like when it prints out. But if I try to print that out, print, parentheses, quote, A equals, end quote, comma, A, like that, it's not going to look like that exactly. How can we get rid of that space? We can choose not to use the comma way of adding onto the string while printing it out, and instead we can use the plus. And again, that's going to crash because we can't add a number to a string, but we can convert this number to a string. Then we can add it to the other one. And now it looks good. Right, it says A equals 6.0 with no spaces. Now, usually we're worried about not having spaces, right? You know, I wanted it to say the number is, and I've lost my space. But if there are times when you don't want spaces, but the print statement is fighting with you by putting spaces everywhere as a comma is, you can choose concatenation instead. And you can mix the two if you really want. This is valid. Print A equals, end quote, plus str, parentheses A, end parentheses, plus question mark, exclamation point, question mark, end quote, comma, beginning quote, wow, exclamation point, closing parentheses. Now I'm going to make it a little bit visually easier to decipher by padding mine out like that. Now when I run it, you see how I got, if I'd put a comma here, then there would have been a space between our number and our punctuation. Right? I would not want to print, you know, good morning, comma, Jeff, followed with a period, right, if the name variable had the word Jeff in it. Instead, I would want that to be gone. I could get that to happen with the print statement. Name is equal to Joe. Print, parentheses, quote, good morning, comma, end quote, comma, name, comma, quote, period, end quote, close parentheses. And we have a period after that, right? We didn't want that period there, so instead of using a comma, I'm going to change that comma to a plus right there. Good morning, Joe. That makes it look good. If I had given it some thought in advance before I wrote it, though, I would have written it with a formatted print statement. Print, parentheses, quote, good morning, comma, %s, standing for string data, period. Because that's the end of the string. I mean, that's the end of our sentence. Good morning, Joe, whatever. And so end quote, %name. Now this %s is a placeholder that's going to be filled in with that variable. So when it runs, it's going to print the same thing as this line did above it. So rather than messing with how to exactly position things with commas and plus signs and stuff like that, my personal preference would be to use a formatted print like that. So we're going to give one more example of a formatted print. Just copy that one, paste it, but then we're going to add on to it where it says good morning %s period A equals %f period. That's the first part of our change. All I did is add that. Next thing we got to do is to put a parentheses before name and then come out after the word name and do comma A and then 2 close parentheses. And I'm sorry that the syntax is a little bit arcane, but what this is saying is that if you only have one placeholder in your formatted print, then after the % just comes one thing, a variable name. But if you have 2 placeholders or more than 2 placeholders, then after the % you have to list all of the parameters that are going to fill in those placeholders, but you have to put them inside parentheses. But that's kind of a quirk to this that you won't see in Java and C# and a bunch of other languages that also have the concepts of formatted print statements.
So like we used %s and then %f. Are they two different?
Right. I used %s because this is string data. Name is a string. So I used %s. This is numeric data. It's a floating point number, so I used %f. If I flip those, it's going to yell at me and say that I can't do that. All right, one more goofy example, and then we're going to be done with this little topic. Message is equal to, quote, I love the number %f, end quote, %a. And now if I print that message out, it prints out, I love the number 7. So we were able to use this formatted string business even outside of a print statement. The print statement isn't the only place where you can use it. You can build a string with it, like I just did here. You know, I created a string, and this operator said, okay, take that data and insert it into the first placeholder and store the results into that string, and then I can print that string out later. It's okay with me if that doesn't click 100% with you. It's totally awesome if it does. For you Java programmers, that's the same as doing this would have been. Message is equal to string.format, parentheses, and don't type this, I'm going to delete it immediately. You know, I love the number %f, end quote, comma, a, like that. Same business. This statement in Java is the exact same as this statement in Python. Anybody have any syntax errors? You haven't been able to get your code to work in a while and you really wish it was? Nope. So when you use the int function to convert a floating point number to an int, it does a round down. So if you really want rounding to occur rather than truncation, don't use int to convert a floating point number to an int. Use round. And I've demonstrated round previously. We've said that if you put a number in, it rounds it to a certain number of decimal points, but if you leave off all the numbers, it just converts it to an int. Now that's a real good example. When we like to print things out, we like to put dollar signs in front of them. Numbers, costs. Cost is equal to, 39.7585. We want to print that out. Print, parentheses, quote, cost is dollar signed, end quote, comma, cost, like that, but it's not going to look super good. Not going to look totally top notch. The reason why is it's going to have a space between the dollar sign and the number there. We can fix that by making it cost plus str, parentheses, cost, close parentheses, and then it looks a little bit better. Or I could have used a formatted print statement, which I probably would do to get it to be formatted with the correct number of decimal points, right? Because if cost is equal to 39.8, the output's going to look a little bit weird. We're used to seeing costs expressed in dollars and cents, right? So we say that 39.80. We like seeing that zero there, and we're not seeing it there. So instead, I would use a formatted print to make it say 39.80. So print, parentheses, quote, cost is dollar sign. And now for our placeholder, %.2f, it's going to round it to 2 decimal places. End quote. And since we're using placeholders, which are marked by the percent signs, we have to use a percent sign to mark that the next variable is a placeholder. And so the result here is that it said cost is dollar sign 39.8. That didn't look good. We had a space where we didn't want it. Next time we ran it with this next statement, it said cost is, it took out the space, 39.8. But this was the best effort. Cost is dollar sign 39.80. Unless I'm specific about it in my homework assignment, I'm not going to yell at you if your output is formatted like with an extra space in front of a dollar sign, right? Or after the dollar sign, I'm not going to go, don't do that. On the other hand, if you are calculating and wanting to display dollars, right, it's a good idea to remember to do %.2f and then feed it in like that, just so that we get dollars and cents like we like to see. So if I make it a bullet point in the homework, express your answers in this format, dollar sign, something, something, dot, something, something, then it's not critical to do that. But it makes your output look better. It ups your game a bit. So Python's organized into libraries called modules. The term module means something completely different than it did in CIT1203. So I apologize for that, but I blame that book, not this one. But that book was calling modules we call functions. And that's what everybody else on the planet calls them. So if you ever hear the word module anymore, it's going to mean a library of code, not a function. And a module can contain hundreds of functions, just like the math module contains hundreds of functions. And quite often I'm going to call it a library rather than a module. I'm going to import the math library, right? It makes it easy to say, I probably should be saying import the math module. So a function is a chunk of code that can be called to perform a task. A function is a named block of code. You have a block of code, you want to be able to repeat it anytime you stick it in a function. Functions may require arguments or parameters. That makes it sound like those two things are about synonymous. They're closely related. We'll talk about the difference in a minute. When a function completes its task, it may return a value. Some textbooks call that a fruitful function. It's a fruitful function because it returned a value. To learn how to use a function's arguments, you can use the help function. Oh, well, that's neat. I'd kind of forgotten that. If I went to the Python shell here, and I typed help, parentheses, SEIL, it should give me help on the math function. But it didn't. Help. Well, let's import the math library. Import math, help, parentheses, math.ceil. And it gives us a written description of what it is. The way it is able to give us this written description is that the person who created the math library added comments to it of a very specific format called a docstring. And then the help function uses that specific style of comment. We'll learn how to do that so that if we typed help on one of our own function names, it would kick that out. But the point is that a function lets you create more than one line of code that you can repeat as many times as possible. You could calculate pi by use of a formula, and it involves a loop and has to run a certain number of iterations, many iterations to get a good value of pi. You know, when they say that the supercomputer calculated pi to the 7 trillionth decimal point, well, it was running a formula and it ran it, it looped a gazillion times in order to get that level of accuracy. But if you were going to calculate pi, and then you were going to recalculate it, and you were going to recalculate it, and you were going to recalculate it, you would not want to copy and paste that code into your program. You would want to break it up into modules. You would want to create a calculate pi module. I just used the word module. Function. Sorry about that. Teaching 1113 too many times. Let's give an example of some functions. How about a function that takes a number and returns it into the form of this string? This is not usually what I demo with functions, but it'll just be one of them. So DEF cost text, COST, and it takes a number, COST, in parentheses, colon, and it returns quote, $, %.2f, end quote, percent cost. And let's write a couple more functions. Define add 3, x, y, z, in parentheses, colon. And what does that do? Result is, or how about r, shorten it. R is equal to x plus y plus z. Return r. And then one more. Define repeat underscore after underscore me, parentheses s, in parentheses, I forgot my colon. I knew I'd forgot my colon because I hit enter and I wasn't indented yet. So was able to catch that by noticing that. I put the colon there. And all I'm going to do is do print S, and then I'm going to and then finally I'm going to print the word OK, question mark. So we've written 3 functions. These are blocks of code. We could invoke this block of code by calling it with a single phrase. Repeat after me. We can invoke this block of code. Now that's, if you have only one line of code in your function, it probably maybe didn't need to be in a function, right? Because this is not so complicated I needed to encapsulate it in a function. Usually your functions are going to be more than one line long. In this case, maybe it's justified. Maybe that makes it so easy to use. So something like this. Print, wait. Message equals, quote, UO, end quote, or UO space, end quote, plus COST, parentheses, 10. And then print that message out. Print. As a matter of fact, let's call repeat after me. Okay, and I'm backspace. I'm going to change that 10. I'm getting rid of that 10. I'm deleting it entirely for now, just so it's not sitting there. Cost equals add 3, parentheses, 10, 20, 30. We're calculating a cost. So we called the add 3 function and added those 3 numbers together. And then message is equal to you owe me plus cost text, parentheses MSG, in parentheses, nope, parentheses COST, in parentheses. And then let's print that message by calling the repeat after me function. Repeat underscore after underscore me, parentheses, message, MSG. And here we see what it did, right? It says you owe $60, and it repeats that message. You know, it says it 5 times in a row. What if that wasn't enough? What if I wanted it to repeat 10 times in a row? Well, since I've already written it as a function, I can just call that function again. Or how about calling it with you better pay up, exclamation point, end quote. So the point being is that we have encapsulated a chunk of code, a block of code, so that it can be invoked with a single phrase, with a single statement. When you have something in between parentheses inside a function declaration, like this, that S, that's called a parameter. A parameter is a variable that gets filled in by data passed to it. Maybe even make that a comment here. S is a parameter. And then I'll add another comment here to that effect. A parameter is a variable that is filled in when the function is called. So when we call repeat after me here, this text got passed into the function and filled in that variable S, that parameter S. So repeat underscore after underscore me, quote, wow, end period, end quote, in parentheses. Wow, or quote, wow, period, quote, is the argument that fills in the S parameter. Very similar ideas, though. You put something between the parentheses. You put something between the parentheses. S is my parameter. I will goof and say, okay, here's my function call, and my parameters are 10, 20, 30. No, technically, these are the arguments that fill in the parameters. And so I should say, here's my add3 function, and its arguments are 10, 20, 30. That is the precise, technical, correct way of saying it. I will goof, and I will say these are the parameters, and I'll just fill them in like that. Just understand that although we kind of loosey-goosey may mix them up, they do have precise meanings. The parameters are in the function definition. The arguments are what fill them in. You can have optional parameters. We're going to define one more function. Define goodbye, parentheses, name equals, quote, whoever you are, end quote, in parentheses, colon. And now we're going to print a message. Print, parentheses, quote, goodbye, comma, end quote, plus name. Since I used a comma, a plus sign, it's not going to automatically add a space, so I'm going to go ahead and put my space there. So if I call goodbye and I pass it a name, goodbye Joe, it's going to print goodbye Joe. But if I call it with no argument whatsoever, it's going to say goodbye whoever you are. I'll bring the text back in just a second. There we go. So you see what it did the first time we called goodbye? We gave it an argument. Sounds like a bad thing. We had an argument. We gave it an argument, so it printed out goodbye Joe. But when we called it and we did not give it a value, when we did not provide an argument, it uses default value instead. And so it printed out goodbye whoever you are. That can be useful. Not to print out whoever you are. But you can make functions that if you call them with no arguments, they behave one way. If you provide additional data by specifying arguments, then it behaves in another way. So functions like ABS and round are from something called the built-in module. That just means absolute value. And round, we've used both of those. And then the math module has a bunch of other functions in it. So you have to add an import up at the top, and then you can use it. You prefix the name of the library of the module, followed by period, followed by the function or the variable that you're accessing from. So math.py. Now a slight curiosity here. If you have the help function, right, the ability to ask for help, can I do help math.py? Oh, I needed to put it in parentheses. Help parentheses math.py. Is that going to work? Cool, that's a lot of information. Way more information than I would have expected. What? Well, okay. Wasn't quite what I was expecting. That's okay. I learned something too. The help function is great for getting help on functions. Not so much if you pass it a variable. So you can avoid the use of the qualifier, the name of the module, by importing the individual resources. From math, I want you to import pi, comma, and sqrt. Or you can get them all. I kind of like seeing the prefix a lot of the times. I like seeing math.sqrt or math. Fsum or whatever, so that I know where that fsum function is coming from. So I don't think that it's something that I may have written. But it's easier to just type print sqrt parentheses 2 rather than math.sqrt 2. Your choice. So program format and structure. Begin your program with the author, the name, the purpose of the program, and other relevant information. We should be enclosing it in a so-called doc string, which is one of those multi-line quotes. Quote, 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 whatever. Then you put your imports, and then you initialize important variables, suitably commented. You prompt the user for input data. You save the input data in variables. You process that input to produce output, and then you display the results. What is the formula for compound interest? Say we're going to write this as homework. We're going to write a program that calculates compound interest. Assuming we have all these variables. We need to turn that into an expression that a computer will accept. I'm just going to default all my variables equal to 1. Or actually, I'm going to do it in Python, just to get things started. All right, so P is equal to 1, R is equal to 1, N is equal to 1, N is equal to 1, and T is equal to 1. Okay, I don't know why I did N twice, except I saw it occur twice in the expression. That's dumb. So I'm going to delete one of those. N is equal to 1. The reason I want to declare all my variables is just so that I will know when this compiles correctly. I'm not going to perform a valid calculation. I just want to make sure that we get the expression right. All right, if I type this, A is equal to P parentheses 1 plus R divided by N in parentheses. How do we take to the power of? How do we go up to a power? Like squaring it or cubing it? Yep, 2 asterisks and then NT. Is that a good representation of that formula? And by good, I mean, does it work?
Yes.
Let's run it and see. And we're going to find out that it's not valid. Going to give us a red cryptic message, int object is not callable. The problem is that we're not allowed to skip asterisks for multiplication. You know, math textbooks and stuff, formulas and stuff like that are happy to leave out the asterisks or the time symbol, the big X or whatever, in order to make things easier to read. But we can't do that. So we have some multiplication here that are not indicated by the star, by the asterisk. So, yeah, fortunately I happen to have my cursor right there. That's still not going to be totally fix it. There's one more of those. The N and the T. It says NT is not defined. This will compile and run.
Supposed to be in parentheses.
Yeah, it's not going to work or work correctly. The reason why is what has higher precedence.
There.
stars, or power of, or multiplication? Power of. So what this is going to do is it's going to take all this to the power of n, and then, oh, now that we're done, we're going to go ahead and multiply it by numbers. So we better put our parentheses here. Now I'm kind of curious. Let's try to give this some good data rather than that. I mean, if we run that, I'm curious what A would be when we printed it out, right? Not that I can tell from that. Okay, 2, whatever. I don't know how to interpret that. I guess it was 100% interest. Right. Okay, so let's add some comments. This is the principal, which is the starting value. Then R is the interest rate expressed as a decimal. One is equal to 100%. And 0.05 equals 5%, just how it's expressed. N is the number of times we're going to perform the calculation. So N is number of times per year calculated. I believe in most savings account it's monthly, right? And then lastly, T is, pardon me?
It's monthly, annually, or quarterly.
Yeah, monthly, annually, or quarterly. You have your choices. And then years. So say I had $100 and my interest rate was 10%. And it's calculated on a monthly basis over 20 years. How much am I going to end up with? Let's find out. Nice. I had to wait 20 years, but I got $700 out where I put $100 in. So we're going to use this in our homework assignment. It might be a fun exercise if I came up with other equations like this. That would not work if, typed in and then, in class made y'all type them in. Right, create a valid expression. You're saying that doesn't sound like fun. Fun for me. Okay, so we are done with chapters 1. We are done with chapter 2. Quiz-wise, I know some people like to work ahead, so I'm going to need to add on a mind type quiz 3. Okay, let's do that. Now this said that the chapter 2 quiz was due on the 11th. That was back when I assumed that we were going to actually finish this a little bit more quickly than we did. I'm going to change that due date, but that due date was really just a reminder. So I apologize making you take the quiz before we were done with the chapter, but it's never a bad thing to read ahead. Alrighty, I think we're going to go ahead and end it here. Let me turn that little bit of stuff that we did into our actual homework assignment. Write a program that performs compound interest calculations. The user will enter the principal, the interest rate, the number of the times per year, and the number of years, and display the result. Real easy based on what we've already got done here, right? Because basically we just have 4 input statements. So a sample run could look something like this. Let's calculate compound interest. And you really all don't have to type this because it will be uploaded as homework, but if you like having it in your file. Principal equals question mark. And you might explain what that is. Nah, we don't have to. Or what is the beginning, the starting principal? They type in something. What is the interest rate? As a fraction, as a decimal. Might even give them an example. How many times per year is interest calculated? 12 times a year. Calculate for how many years? 20. And then display the results. So we would display the result is, and we'd like it to be nicely formatted with a dollar sign in front of it and then 2 decimal places. The closer you get to this, the better, right? I'm not gonna ruin your day if you put typos in it, right, or something like that. You'll still make a perfect grade. But I really would like for y'all to format it like that, and I've demonstrated that several times now. You don't have to go overboard and create a function like I did. Just use that print %.2f, right? Hint. Use print parentheses, quote, blah, 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 dollar sign %.2f, end quote, comma, value, to round the money amount appropriately, or to format. That make sense, guys? Okay. Alrighty. Have a good weekend, y'all. I'll see y'all on Tuesday. Any questions at all?
Did you create the Lecture F Dropbox?
I will do that. Trying to send you out of here without having that.